Students, if you have given any of this type of formula and you have asked which will be its 1H NMR or what will be its 19F NMR or what will be its 31P NMR or 31P proton decoupled NMR or what is the 13C NMR, can you find out? No, then this is the video that you should watch must be. Okay, so please watch this video till the end and cover all the topics of NMR in a single video. Hi students, I am Priyanka Jain and in this lecture we will study all the types of NMR with the help of one example in a single video in no time. Okay, so let's start our lesson. Firstly, see this compound. We have given this one is the compound and now we have to find out its 1H NMR, 19F NMR, 31P NMR, 31P proton decoupled NMR and 13C NMR. Okay, so watching them one by one. Firstly, watching the 1H NMR of this particular compound. Okay, so how this will look like. Now in this compound, you can guess how many types of protons are there. You are firstly watching the 1H NMR, means to say you have to see which one type of protons you have given. You have to judge only the protons. Okay, so now there is the number of protons. See here, these 3 protons and these 3 protons. These are in the same environment. So we are numbering them as A type of protons. These are A type of protons. Now see the next type, this one. See here, I am highlighting this one. Okay, so this is called B type of proton. Okay, now see the third type of proton that you have given, this one. See here, this one. This is the third type of proton that you have given. This we are marking as C type of proton. Means to say there are 3 different types of protons. So you are getting 3 signals. Okay, now firstly see the signal for A. Signal A. Signal A, you are getting, if this signal will be in the contact of this phosphorus atom, you can see there is a phosphorus atom present here. Okay, so these 6 protons, these are coupling with this phosphorus atom. Okay, because this phosphorus is also NMR active, so their nucleus will couple together. Okay, so by their coupling, we know for phosphorus I is equal to half. Okay, so what will happen, there is only one phosphorus nucleus, so this signal will split into 2 and I plus 1 lines. Okay, so I value is here half and N value is 1. Means to say this A signal, that is 6 protons. Okay, this 6 protons will split by 1 phosphorus into 2 and I plus 1, means 2 into 1 into half plus 1. It means this signal will split into 2 lines. You are getting 2 lines, means you are getting a doublet. Now see the second one signal. Second signal is due to this B type of protons. This B type of protons are now in contact of these 2 fluorines. You can see these are 2 fluorines and this is the phosphorus. It is in contact of this phosphorus. Okay, this is in contact of this phosphorus and these fluorines. So it will split 2 times. Okay, these 2 protons will split their signal 2 times. One by the phosphorus, because there is one phosphorus, so we are getting 2 lines. Again these 2 lines will split by these 2 fluorine atoms into 3 lines. Means to say, if you are judging, see here I am showing you, this is the A signal. This A signal I have shown you that this get split into 2 lines. Means to say you are getting doublet due to A type of protons. Okay, now see the B type of lines. The B type of lines means B signal. This firstly couples with the phosphorus, so you are getting 2 lines. This is called J, coupling of protons with the phosphorus. Okay, you are getting 2 lines. Now each line get split again by the 2 fluorine atoms into 2 plus 1, means 3 lines. So you are getting 3 lines in this manner. This is due to J proton with fluorine. Okay, so in this way you are getting 2 triplets. So I am writing here, you are getting 2 triplets when you are seeing the signal of B type of protons. Now let's see the C type of protons. See here, these are the C type of protons. These are in contact of only the fluorine atoms. Okay, So now the number of fluorines is 2. So this will get split into 3 lines. Okay. So I am showing you here C type of signal. The C type of signal will split by these 3 fluorines into a triplet. So you are getting a triplet here. Means to say, in one H NMR, you are getting 3 signals. One will be a doublet, another will be 2 triplets, and third one will be 1 triplet. In this way, you are getting 3 signals. Now let's take a look of the 19F NMR spectra. Students, one thing I want to tell you, if you are liking my videos and if you want a detailed course, then my detailed course are available on my app. Okay, so you can visit my app. The link of the application and the courses are given in the description box, so you can watch there. Okay, so in that courses you have given whole type of NMR spectroscopy and whole the courses. Okay, so you can watch that courses with the PDF. Now take a look of the 19F NMR spectra. In 19F NMR, we will judge only the fluorine atoms. There are 2 fluorine atoms. They are identical environment. Okay, so they will give rise to 1 signal. Okay, so you are getting 1 signal due to 2 fluorine atoms. Now this signal get split. Okay, this signal can split by its nearer protons. Okay, because in its surrounding there are only protons. Okay, so it is splitting by this proton nucleus. Okay, so there are 2 types of protons. These are 2 protons of one type and these are 3 protons of one type. They are non-equivalent. Okay, so the signal will split firstly by any of these 2. You can do by any of these splitting. No matter, this is no matter. Okay, so see here. Firstly, I am taking the signal. It get split by 2 protons into a triplet. Okay. Then this will get split by 3 protons into a quadrate in this manner. So either you can make in this manner or you can make in this manner. Firstly, you can split by the 3 protons in a quadrate. Then this quadrate can split by the 2 protons into triplet in this manner. Okay, any type of splitting you can give, you will get the same answer. Okay, because you are getting 12 lines. Okay, so in this way you are getting the 12 lines in the 19F NMR spectra. Now come to the 13C NMR spectra. See here, if you are looking at the 13C NMR, then you are looking only the carbon atoms. Okay, there are 4 type of carbon atoms. This one. Okay, these I am calling A type of carbons. These are A type of carbons. Then there is this one carbon. This is called B type of carbon. This is C type of carbon and this one is D type of carbon. So you are getting 4 signals. Okay. So now watch which signal will split or which one will not split. See here. Firstly, you are seeing the A type of carbon atoms. These A type of carbon atoms are in contact of 3 protons. Each carbon is in contact of 3 protons. So it can split by 3 protons into a quadrate. So you are getting A type of signal that will split. This A signal split into a quadrate. Means to say you are getting 4 lines here. Now see the B type of carbon atoms. The B signal is in contact of 2 protons. So B signal will split into a triplet. 2 plus 1 into a triplet. 3 lines you are getting here. Now come to the C type of carbon atom. The C type of carbon atom is in contact of 2. This will be fluorine atoms. Okay. So it is in contact of 2 fluorine atoms. So now again the fluorine is also having the I value is equal to half. So same thing will happen. 2 plus 1 means you are getting 3 lines again here. So we can write here that C signal split into a triplet means you are getting 3 lines. Now you can judge the D type of carbon atom. The D type of carbon atom, this is the D type of carbon atom. This is in contact of the 3 protons. So you are getting 3 plus 1 means 4 lines. This will split into 4 lines. So the signal split into a quartet means you are getting 4 lines here. So if you want to make, you can make 4 signals. I am showing you. See here how you will have to make. You have to make 4 signals. Okay. One you are getting a triplet. Means to say, in this way you are getting a triplet. Again you are getting another signal that is a triplet in this manner. And the third signal will be a quartet. Their positions may change. Okay. I am just showing you so that you can understand. Their positions will depend on the chemical shift. So in this way you are getting 4 signals. Okay. So this is the 13C NMR spectra of this particular compound. Now we see the 31P NMR spectra. Suppose you have asked about the 31P NMR spectra, then you will judge only this phosphorus. This phosphorus is in contact of protons only. We will not judge the carbon atoms. Why? Because in the case of carbon, the radioactive isotope has very little amount present. Okay, its percentage is very less, so you are not getting a high peak. Okay, so this will be very small splitting. So you will judge only the proton splitting. So there are 3 and 3, 6 protons of one type. Okay, these are A type of protons here. See here, these are A type of protons and these are B type of protons. Only we will judge by splitting by them because these are in the nearby of phosphorus. Okay, so phosphorus signal. Phosphorus gives one signal. This one phosphorus signal will split by 6 proton into a septate, means you are getting 7 lines. Then these 7 lines will again split and there will be again splitting. Each line will again split by 2 protons into a triplet. Okay, so if you are seeing the lines, how you can see the lines? You are getting one signal in this manner. This get split by anything you can do. Firstly, you can do the splitting by these 2 protons. Then you can do the splitting by these 6 protons. So I am doing the splitting by firstly these 2 protons. So you are getting 3 lines. Then these 3 lines get split into septate. Means 1, 2, 3, 4, 5, 6 and 7. Similarly, 1, 2, 3, 4, 5, 6 and 7. Similarly here 1, 2, 3, 4, 5, 6 and 7. In this way you are getting here 3 septates. Okay, this will be the 31P NMR spectra. But sometimes you have given in this manner 31P and in bracket you have written in this way 1H. What is the meaning of this thing? This means proton decoupled NMR, means we will not see the splitting due to the protons. Means in the surrounding there are protons, but we have to consider no splitting due to these protons because this coupling has been decoupled. Okay, so you will have to write only you are getting one signal. Okay, no splitting. So you are getting one signal. I hope you get understand whole type of concept. If you want more details of this type, then you can watch our app. You can visit our app and then you can buy the course. Okay, full PDFs you will get with the test series. Okay, so if you want, you can go and purchase the course. Thank you.